Everybody, welcome back to another fun and exciting Algebra 1 class. Today we are going to be in lesson 12.3. That starts on page 460, page 460. We're going to be talking about the domain of a function. In this chapter, we've been talking about functions and how they act and react in different situations, and today we're going to talk about what's called their domain. Now, the domain is a little bit complicated, but over the years, I think I found some different ways to help students to understand it. If you look down here at the screen, the domain of a function is all possible input values. Okay, so what does that mean? Whatever number you want to put in for x, since x is your input value, whatever number you want to put in for x, you can put in for x. Okay. However, some of these functions are going to have limits on the x. What do I mean by that? Notice what it says. It says these are the x values that do not invalidate the function. Okay, let's look down here. I've got some reasons an x value can invalidate the function. What does that mean, to invalidate? Well, to make it not valid. You say, Mr. Steve, you can't use the definition, you can't use the word in the definition. Well, I just did, so deal with it. So what does it mean to invalidate, or what does it mean to be valid? To be valid is just to be true, or something that always works. To be invalid is something that's false, and it doesn't work. And something can be invalid sometimes and valid other times, and that's what we're talking about with the x. Some values that you put in for x can make it valid. It works. Other solutions for x, or other inputs, if you will, make the function invalid, and it doesn't work. All right, what are some examples of this? Well, here you go. Look at this. Number one. If it yields more than one output value, then it's not a function. So if what you put in for x gives you more than one solution, then it's not a function. So that x value would invalidate the function. Another way is if it yields a math error. What does that mean? So you put it in there into your calculator and you hit equals and it reads back math error, or invalid, some calculators say. In other words, you put we just did these in the last chapter. You put a 0 in the denominator. If there's a 0 in the denominator, invalid, math error. Okay, it doesn't work. So we've got to look at some of these and say, okay, if I put in 3 for x, in this case, it's going to give me a math error, so 3 is not part of the domain. The domain is anything that works, okay? Exclusions from the domain is anything that does not work, okay? So let's talk about, what does this mean? Let's look at some examples of this. In polynomial functions, the domain equals all real numbers. So in other words, anything we put in for x right here works. We can't put anything that makes it go invalid. You can try anything you want. You want to try -5 and -5, it will give you one answer. You want to try 0 and 0, it's fine, it will give you one answer. You want to try 3 and 3, you want to try 1 million and 1 million, it's fine. So it doesn't matter what you put in for x. Why not? Because there's no fractions there, there's no absolute values there, there's no radical sign there, there's nothing that can be like what we would call maybe like a qualifier, something that qualifies the x, or that the x has to meet a certain standard before it is a function. So in polynomial functions, here's your answer to these. Whenever you get something that looks like this, where it's just a polynomial, so there's no fraction, there's no radical, there's no absolute value, there's nothing else in it, it's just a polynomial, the solution is all real numbers. That's it, all real numbers. You don't even have to solve it, okay? Because you know that if it's a polynomial function, the solution to the domain is all real numbers. All right. Radical function domains. So now we have a radical sign. And notice I don't write f to the x. I wrote g to the x. What's the difference? Well, it's just a different function. So like if I had these two functions together, I couldn't use f again. Why not? Because it's already used. I've already defined this function as f. So I'm going to define this function as g. It's just a different function, but it's a g function. This, when it's in italics like this, I try to write it in italics. I don't know how good that is, but when it's in italics, you know it's a function. So when this together is like that with the italics here and with the x in parentheses, you know, okay, that's the g function. All right, so let's focus on this right here. When we learned, this was back in chapter, I don't know, 8 maybe, when we learned about radicals, what did we learn? One thing that we learned is we can never have a negative sign inside the radical. Why not? Because no two numbers can give you a negative number. Okay, so you can't multiply -2 times -2 and get a negative. No, it's a positive 4. There's no way inside a square root sign to have a negative. And you say, but there's a negative right there. I know. So how can we solve this? How can we figure out what the domain is for this one? Well, x has to be something that makes this positive. Here's the way that you do it. You set the radicand equal to 0. Or we heard it called the discriminant too. So this area in here under the square root sign, x minus 5 equals 0. Solve for x, plus 5, plus 5. So we know that x has to be equal to or greater than 5. So how would we say this? What if we said x equals 5? So 5 minus 5, is that okay? 0. Yeah, that's fine. What's the square root of 0? The square root of 0 is 0. Okay, so that one works. But what if we say that 4, what if we call x 4? What if we say x equals 4? 4 minus 5 equals -1. Is the square root of -1 a thing? It's not. And so this one will not work. Okay, what else won't work? Anything lower than 4 won't work. 0 won't work. -1 won't work. 2 won't work. Anything. So here's the way that you would write this. You would say that x has to be equal to, well, let's write it like this. It has to be greater than or equal to 5. That's how you would write the solution there. X must be equal to or greater than 5. If it's equal to 5, it works. If it's greater than 5, it works. If it's less than 5, it doesn't work. Okay? Next, the rational function domain. So how do we do rational functions? Well, let's review. What's a rational function? Last chapter, we learned that a rational function is a fraction, a polynomial fraction. So what did we learn in that chapter? We learned that the denominator cannot equal 0. What happens when the denominator equals 0? Math error happens. Take a look at my calculator and look at what it does if I try to divide something by 0. 9 divided by 0. Look what it does. Cannot divide by 0. Basically, it's saying, math error. Can't do that. What are you thinking right now? Invalid, invalid. So, since it's invalid, we can't have 0 as the denominator. So what should we do? How can we figure out what not to include in our domain? So our domain can be almost anything in this one, but it cannot make this denominator go to 0. Do you remember how to do it from the chapter? What we do is we set the denominator equal to 0. In this case, since it's a quadratic, there are 2 things that could make our denominator go to 0. So we have to factor this. Our factors are going to be minus plus, and they're going to be factors of 8 that add up to -2. So let's try 4 and 2. Well, the 4 has to be bigger, and the 4 has to be negative and the 2 has to be positive. Why? Because we need that to go to negative. So when we FOIL this, we would get 2x and FOIL this, and we get negative 4x. Combine those, and we get our negative 2x, okay? So that is definitely our factor. And now what do we need to do? Well, we need to set them both equal to 0. X minus 4 equals 0. X plus 2 equals 0. Move it over. X equals 4. Move this over. X equals negative 2. Or remember what we said in the last chapter. Better said, it's x cannot equal 4 and x cannot equal negative 2. So here's how you would write this one. You would say all real numbers, and then you'd say something like except 4 and negative 2. Something like that. Or you could actually write it with x cannot equal 4 and x cannot equal 2. However you want to do that. Let me show you one more. This one's a little bit interesting because this one's kind of got a little bit of a double going on. Notice up here in the numerator we have a radical. Notice down here in the denominator that we have a rational, because we have a denominator. So there's two things going on. So what you need to do is you need to solve both of them. So how do you solve the radical? Set it equal to 0. X minus 3 equals 0. Move 3 to the other side, plus 3, and we get that x cannot equal 3. It's not just that, though. This is important. This is where you can't make this mistake. It's not that x cannot equal 3. X can equal 3, because we could have 3 minus 3 equals 0, and 0 inside the radical is fine. So don't get confused by the rational. Finish that out. By the rational and by the radical. The radical, you would say x has to be greater than or equal to 3. In other words, x cannot be less than 3. So that satisfies the numerator, that satisfies the radical. Now let's look at how do we satisfy the denominator. Well, in this one, we just set it equal to 0, just like we did up there. It's gonna end a little different, though, because we're going to get positive 5. So now we say x cannot equal positive 5. So those are our two answers. We would say that x has to be greater than or equal to 3, and x cannot equal 5. Okay, so those would be the two answers for that one. So be careful if they give you a double, where you have two different things going on, like a radical and a rational, in the same question. Okay, so let's review real quick. Reasons why x value cannot invalidate the function. Okay, number 1, it yields more than one output. Number 2, it yields a math error or an invalid output. In polynomial functions, all real numbers work. There are no exclusions there. In radicals, we set it equal to 0, and then we put the greater than sign, or less, potentially less than, but for the most part it's going to be greater than, because we have to keep it greater than 0. And then we have here the rational function domain. We set the denominator equal to 0, and we say, okay, these denominators cannot equal, the x in the denominator cannot equal 4, and it cannot equal negative 2. All right, well, I hope you learned something there. If you missed anything, make sure you slide it back, watch it again. Try some of these. Go practice. That's going to help you out a lot for your quizzes and tests that are coming up. All right, we'll see you later. Bye-bye.